Right. Well done for staying. We've culled out the group to the serious people. I'm sorry, I shouldn't say that. Don't, whatever you do, don't pass that one on or tweet it. That would be really bad. That would be me. That's probably a guarantee it will get passed on, isn't it? Okay, what we're going to look at today, probably the one area that I think is probably going to cause the most hassle in school. Although I think the programming is going to be an issue with a lot of schools, this area here I think is probably going to be one thing. In a way, in the old days, we had the sort of control aspect of the curriculum. And as an ICT AST, I went into loads of schools. It was done pretty well at Key Stage 1, but it was done pretty awfully at Key Stage 2. And I can see that actually this area might actually sort of become that sort of area that people sort of skate around and don't really do. So we wanted to do a session today and talk through some things and ways that you can sort of pass some of this on. And I've also got some planning that's part of this as well. That'll help you to sort of take back and pass on and also understand it yourself. And I think that's sort of part of it. It's difficult to teach anything if you don't really understand it yourself. So this is the sort of justification from the curriculum, first of all, for sort of covering this. Okay, understanding computer networks, including the internet, how they can provide multiple services such as the World Wide Web, okay, and the opportunities they offer for communication and collaboration. I tend to think the opportunities for communication and collaboration tend to be the sort of digital literacy stuff that we've been doing really well over many, many years. We don't want to throw that away. We're going to keep a chunk of that stuff and carry on with that. But of course, understanding how it works is pretty new. Really. And of course, we've got this little how search technologies use search technologies effectively. Well, I think schools have been doing some stuff around that for years, okay, but appreciate how results are selected and ranked. I think that's probably the sort of an issue for a lot of people. Okay. So what we're going to do now is we're going to hand over to Les, who's going to do a bit more of a bigger picture of how it all works, and then I'm going to come back and actually focus in on how we can do things, how we can adapt what Les has been doing for schools, and give you some things you can take away as well. Is that all right? Fantastic. There we go, Les. Okay. So.
Right. So thanks very much to Phil. The internet, of course, and the web. When you think about how it's developed over the last 25 years, we're in the 25th anniversary that they're celebrating at the moment of the conception of the World Wide Web. You know, its first idea when Tim Berners-Lee, who invented the web, I've mentioned him before. I was trying to get a plug for the fact that he's a professor here to make it sound more important. He worked at CERN, which is the European Central Research Agency, which is where they developed the Large Hadron Collider, and we've had all this stuff about the Higgs boson. And I'm sure it's not part of the curriculum, but I'm sure you're keeping up to date. He was working there, but of course he wasn't Swiss, he's British. He grew up in Poole, actually. He's quite a local boy. And he developed this thing called the web, but of course what he invented was something that was almost completely different from what we've turned it into. And so the things that, if you ask people, well, when you say the web, what kind of things do you think of? What do you use? What's your experience? They'll talk about Googling for things, looking up things in Wikipedia, or if you're a bit younger, looking up things in YouTube. Sort of using Facebook or Twitter to keep in touch with your friends, taking selfies and uploading them to Instagram on your mobile phone. And none of those things were there in the original World Wide Web, of course. We didn't have smartphones. And when Facebook first came out, a matter of 10 years ago, it was restricted to universities only, and to university students. and in fact your university had to apply to be allowed to be part of it. So, you know, so things have changed, you know, sort of really quite a lot, and the web has grown hugely. It's this enormous thing. We used to, all the different web search engines, remember when there were different web search engines? Used to vie for, oh, how many pages have you got? We've got 10 million pages, we've got 100 million pages, we've got 500, and every couple of months they used to, you know, sort of come up with new statistics for how good their coverage was. And the appetite for that kind of left everybody once we were getting to 8 billion pages and counting, and no one could really work out, you know, sort of what it meant to have a page on the web anymore, and, you know, sort of all these databases. Do you include every single comment page on Amazon, for example, as a, you know, so no one could work out how to count it. And you've got this enormous thing that's stretching over the whole planet, and it's huge, of course. You know, sort of billions of pages, all, and this is a special thing about the web, all linked to each other. You know, every page containing links to every other page, all massive, you know, sort of massively tied in together. And it's really difficult to get kind of a human scale on that sometimes. And so I was trying to think about what's an experience that we all have where you're dealing with something really big that's really linked together and tied up and tangled in a way. And so I thought of Christmas fairy lights. And the thing about those is that you have, in order to use them properly and make sense of them, you have to have them all undone, but they're inevitably, when you get them out of the box, and if you're like me, you probably wind them up really carefully each year on January the 5th or later if you can't be bothered, and somehow when you take them out, they have miraculously kind of decomposed into this incredible tangle. And so you spend ages trying to do it really carefully so you don't break any wires or any bulbs, and you kind of tease them out as best you can until you get them into, you kind of see what shape they're supposed to be that you can actually use them in. And of course some of them look like this, they're a straight line, but some of them, you know, sort of nowadays you have these curtains of Christmas lights. I don't know if anyone's got those, you know, sort of I hung them up down our banisters one year, which is fantastic for a year, and then I just couldn't untangle them the next year, and so I didn't use them. But they have a natural shape that you have to be able to understand in order to use it. And so to some extent, the web is a bit like that. The web is this tangle of things with my homepage referring to, you know, sort of where I work and other companies that I've collaborated with, other universities I've collaborated with, and sort of my personal stuff and my friends, and my LinkedIn page, my Twitter page. My Twitter page has links to loads of photos and other people's Twitter pages, and they link to loads of, you know, sort of news and all sorts of things, and everything is really, you know, sort of tangled up. And so if you're someone like Google, a search engine, who needs to make sense of all this, who needs to try and tease all the unnecessary tangles apart and see for the whole planet, you know, so for google.co.uk and google.fr and google.de and google.au in Australia and google.sg in Singapore, for the whole planet trying to untangle that mess, which is kind of challenging. And do you know what they discovered? What shape it was? Was it a line? Or was it a curtain of lights? Do you know what shape they discovered when they looked at this? They tried to do some really big scale studies of, you know, what the web looked like. They discovered something that looked like a bow tie. Now, this was not what anyone was expecting. And in fact, how can this thing look like a bow tie when you untangle it? It turns out that there is what they call a strongly connected core. If you think of the web, if you think of all the really massively popular pages that all link to each other somehow, and so from one page you can get to another page, and you can kind of click on one link and go to another link and go to another link, go to another link and go to another link, and you could work your way around the whole web just jumping from page to page. And if you did it long enough, or if you had, if you had an infinite number of monkeys with an infinite number of web browsers, you'd be able to, just by clicking, you'd work your way around the whole web. Okay? And so that's what they call the strongly connected core. So if you're clever, you'll have noticed that the numbers in here don't add up to 8 billion. This is quite an early study. I won't go into those details. Then they found there are these two, and that's the bow tie bit in the centre, the knot. And then you've got these two bits on the outside. There's the in bit and the out bit. And the out bit is you can get from any of the places in the really popular well-connected lot. So it's a bit like a social network, isn't it? Very well connected. You could get to the outcast, the out region, and that you can get out to them because there are links to these pages, but they don't link back into the popular page. They're just dead ends. So once you end up in this region, you can't get back there. All right. And then you've got the in bit, which is the opposite. So you've got all of these kind of a new person comes onto the internet. They create their own profile page on Facebook or something, and they link to loads of other people, and they link to they like lots of things and companies and events and activities, but no one takes any notice of them yet. No one's linked back to them, and so you can't. From that region, you can get into the central core. So the web has a structure. There are all these bits around it, so it's a bit unlike any bow tie you've ever seen. They have these tubes and tendrils and things. But this is done by computer scientists. Computer scientists aren't known for smart attire necessarily, so it's what they think of as a bow tie. So how does that work out for actual computers? So this is a picture of a data center that Google might have, and all the racks and racks of computers and storage and network that you have in there. So Google has dozens of these spread across the planet, all of them trying to find out about what's going on the web and trying to find out and trying to do things with it. Their motto is, we want to organise the world's information. So it's like organising your Christmas fairy life. How do you take this mess that's out there, put it into some way that you can work out and understand what's going on? So I would like us to try out and do something a bit like Google does, so for which I will need 4 volunteers. And the special requirements for these volunteers are you must have your own pen, or possibly a pencil. So could I see 4 really keen hands? Oh, 1 really keen hand, 2 really keen hands. Could we have a gender balance, please, now? 3, 4. Thank you very much. Would you like to come down to the front with your qualifying pens? Thank you very much. So I'm going to, because of the, yes, so what's your name? Denise. And you are? John. Debbie. Adam. So, Denise, John, Debbie and Adam, I want you to be agents of Google, going around and finding out what information you can from the good folk here. 1, 2, 3, 4. I should have done 1, 2, 3. The bad classroom practice 4. So, in particular, I'm going to limit this to smartphones. 1, 2, 3, 4, and 1, 2, 3, 4. So, I'm going to try and find, I'm just going to do a Google about smartphones. So I want you to find out for me, smartphones in the room. Who's got one? What's it like? In fact, I've got a set of questions for all of our searchers. So I want you to go into the audience. You can divvy the audience up how you like, whichever people you like the look of. And I want you to find out, the people who've got a smartphone, I want you to note where is this smartphone, what sort of smartphone is it, what condition is it in, and what software is it in, what apps, or what, is it iOS or Android or Symbian or whatever. And so, yeah, can you just do that for a couple of, just really quickly, you've got, so write one, try and find 4 things and write them down. Thank you very much. Notice how the searchers have started off right from the front. Looking for smartphone. I feel like a BBC News 24 commentator. I'm standing outside number 10. So perhaps we might want to extend the search out to somewhere a bit further. I can see already that I'm going to have to, we'll cut down the number of smartphones you have to find to 2.
It's well protected.
All right. And you see what we're doing here is a bit like how Google works. And so, how does Google know everything that's on the web? I mean, clearly it's not like this, because when someone types in smartphone into the Google box, it doesn't just say, hang on, and then go and ask all the different web pages, have you got anything about smartphones? Clearly it's not going to do that. It's done this all in advance. But what it has done is sent out lots of agents, lots of bits of software, things that we call spiders or crawlers, using the analogy of the web, that go around every single website and look at everything that's on every page in that website and stores it back in an enormous data. Ooh, that's the wrong button. An enormous database like this, which is why Google needs such a big data center, because it's storing the whole internet. It's basically taking a copy of the whole internet, page by page, and because what people want to know about these pages is what words are on. They look for particular words, the word smartphone, or Lady Gaga, or X Factor. And so you want to know which pages have got those words on it, and so it takes those and puts them in an enormous database. Could I call my spiders back and see what we've got in our database? Right. So let's have a look here. Oh, wonderful. I'm seeing. Oh, we've got some. What words have we got? What kind of smartphone? We've got some iPhone 5, an iPhone, Samsung, and an iPhone. 3-1 to Apple there. Samsung Galaxy 2, iPhone 4. You're very high end here. iPhone 4, iPhone 5. Fantastic. iPhone, Samsung, iPhone. I could sell this to a market research company. Oh yes. So so we've got lots of phones. That's great. I wonder if we've got an HTC phone anywhere. I'm going to search. Oh gosh, it's an HTC phone. Okay. Right. You can see why we're going to need a database here. So we're going to have something that can look up all of these words really quickly. But now, this is an interesting question. Where So we put second row end, fourth row middle. Whose was this? Okay, so you've decided to identify people by where they're sitting. Yes, third row 2, back left, front left 3. Oh, what's this say? Someone put question mark Den.
Oh, that was his name, because I said, because he put a question mark, I said, well, what's his name?
Oh, okay. So you tried to find out what he was called. Yeah. Okay, now see, that's really interesting. How do you find, if we wanted to identify something, how would we do it? We could count the number of rows and count the number of seats across, and congratulations for doing that, because that's kind of tricky. Or you could do something like give someone...
So this is what I did here, like here, someone actually identified.
Okay, brilliant. Give someone, yes, you could do it by the geography, the layout, by the name. No one put personally identifying features of the person with funny hair and bad dress sense. No one has written that. So, but you can think of ways of identifying where people are. Now the web has a way of identifying people, not people, well, people and things and web pages. And photos and music and videos, and they're called URLs. And we do it by pointing at an internet server, at a computer on the internet, so something like www.google.co.uk, and then kind of giving those slash this, slash that, slash the other. So all our URLs look like that. They're a mixture of pointing at, so it's like saying the row that you're in is the server, and sort of what's the file name in there. You're doing that. It's a two-stage thing. So we've got that. Now what condition? New, newish, 18 months old, well protected, good. Okay, good. So we've got a lot of, oh, rot. Gosh, I can see that's a problem. So you've got lots of these things. So if I wanted to find, a good smartphone, I could look in there and see how you've rated it for how old it is, how modern it is, what condition it's in. And so, of course, that's something that's terribly important. We need to be able to rate this information because there's an awful lot of it. I mean, we found all of this just in a few minutes. How many people have got smartphones here? Right, you see, it would have taken us a long time just to do that. Much less to search for the smartphones of everyone on the planet, much less to search for everything about everyone on the planet, which is what Google's trying to do. I'm going to say thank you very much to our 4 web spiders. Thank you. And I'm going to say, this turns out to be really important. So I don't know, how many of you can remember back to the first search engines? Yeah. I remember when, anyone remember Alta Vista? That was the first search engine. I remember where I was in the Boston Computing Museum, because I was at the World Wide Web Conference in Boston at the time, and not Compaq, who they were before, a computer manufacturer, announced this Alta Vista. And I thought, this is crazy, no one can do this, no one can index the whole internet, it must be some sort of hoax. And it turned out not to be. Yeah. And so, but the problem with them was, you got 100,000 results in no particular order. And it was really difficult, you just had to go through page after page after page. And Google invented something that was really interesting. They invented a really interesting way of ranking things. And they have this really clever piece of mathematics called PageRank. And it's all based on not just how many times did your page talk about smartphones, how many times did it mention the iPhone. The more it mentions the iPhone, obviously the more relevant it is, and we'll put your page at the top of the list. That turned out to be a really bad idea. What it looked at was how many people mention your web page, how many people link to your web page, how many people respect your web page enough to link to it, and they think of it as a kind of a vote. So if you're writing about something like primary computing, and lots of people mention you and link to you, you get a lot of kudos, and you get a lot of what Google calls PageRank. And so you end up with this whole, the web is like a whole nest, I don't know where that came from, lots and lots of pages, some of which are clearly more important than others. So Facebook's homepage, you know, everybody, you know, sort of links to Facebook. So Facebook is one of these big things, really important. It's got lots of page rank. But if Facebook or the BBC News or the Wall Street Journal or any of these things link to you, then that's considered a really quite a significant vote. Yeah, okay, these really important people link to you, so you get good page rank. Whereas if it's just, you know, sort of, if it's just Les Carr or John Doe, something that no one's ever heard of and links to you, yeah, all right, just a little bit of importance, you get a little bit of importance. And so you basically go around and see, look at all of your stuff, who's pointing to it, who's mentioning it, and if it's important people, you get lots of kudos added to you, lots of page rank. If it's not very important people, then not much. And you just keep going around and adding up, doing it for everything in the internet. So it's, you know, it's easy to say, isn't it? That's why they've got these big servers. And that turned out to be the secret of effective search. Not just looking for words, but looking for this pattern of votes, of linking, of confidence, of people saying, yeah, I really like this stuff, I'm going to mention it. And that's a big secret in the development of the web, of making something that was really effective for the search. I'm going to hand over to Phil now, who's going to talk about, well, he's going to say, that's all very well, but how can you do this in the classroom?
I certainly am. Okay, so thanks for this. I love the analogy of the fairy lights. I think that's brilliant. So I think interesting. We've got some idea of this, but how do you actually really transfer this into the class? All right. Now I've been doing this mostly in Year 5. All right, but I think it's probably an activity that you could do in Year 5 or 6, really. So really, the first thing I do is actually I ask the kids, if you're at home, all right, and you'd lost something at home, okay, who would you ask to help you? And you would, well, let me ask you, you know, in your house, who would probably people go and ask? Mum? Fantastic. Anybody? Who else would vote for Mum in the house? Yeah, got mostly the mums. Anybody dads here? Okay. It was very interesting. One or two. Now, obviously, it depends on your home, doesn't it? But when we asked the children, out of a class of about 30, about 12, 13 of them would say Mum, and 1 or 2 of them would say Dad. Now, what they're really doing here is they're using Mum's stored knowledge, Mum's index, okay, or Dad's index of where things are. The fact that, you know, let's be honest, Mum or Dad have been cleaning around at some point and they've spotted that actually you've left your skateboard under your bed, okay, and they've put that in their brains, and so the next time you ask, where's my skateboard, they go, look, yeah, you should have put it outside, but it's under your bed, isn't it? Okay, so you're using Mum or Dad's stored knowledge, their stored index of where things are, okay? So actually, Google works a little bit like asking your mum where something is at home. All right, now let's take that into a sort of a fun thing here. So let's take that a little bit into the classroom then. And one of the little activities I do with the children, so I'll talk through that, and then we say, well, okay, and we explain that if a little Year 3 was going to come into your Year 5 classroom and they were going to start looking for pencils, a bit like some of you started going around finding that information about smartphones, all right, they'd of course have to go around and they'd have to look for colour pencils, and they'd be like checking out the trays here and checking out the teacher's desk over here, and here's the cupboard, and it might actually take them quite a long time to actually find something. But we can make a list, or we could make an index of where everything is. in the classroom. And of course, if they then had an index, all right, they could just go and have a look at that index and say, oh, colour pencils, and they could find the best places for them. So what we then do is we get the kids to actually go and make a class index. And we give them about 10 minutes and we say, right, okay, you two, you are going to go and look for coloured pencils around the class. We give them a sheet, they have to write all the location of every coloured pencil in the class, and they have to say how many there are of that type. All right? And then we might go over here, we might say, okay, you guys, you're looking for displays in the classroom. You've got to find all the different displays, where they are, and how many bits are attached to the display. Okay, and you guys over here, you're going to do rulers, and you're going to do rubbers, okay, and we've got a whole sort of list of things. And we give them about 10 minutes, and the poor person who's going to do plain paper comes up, Mr. Bates, do I really have to count every piece of plain paper? And you say, yes, you do, sorry about that. Give them a bigger group, and they just go through and do that. And then we come back, and we say, okay, that's cool. But can you work with the person you've been going and doing this with, and can you just, okay, here's a little example of them filling in that sort of search index. And by the way, all this planning, I'll show you where it is. It is all downloadable, and it is usable, and it is all free on the web as well. Okay? So they fill this in, they say the number of items, okay, and then we come back and we say, well, actually, out of all your locations you found where you found things, what was the best location? You discuss that amongst yourselves, and the kids come up, and then you get some feedback after about 2 or 3 minutes about what they thought was best and why. And actually, it's really interesting. They will say things like, well, okay, coloured pencils say. We think that although there were more coloured pencils down over there, we think the best location was actually in the teacher's desk because they were all new coloured pencils. All right? And we all like new coloured pencils because they're all sharpened and ready to go. Or they might say, well, okay, reading books. We've chosen this big standard display of reading books as the best because it's right near the door and it's easy to get to. Okay, so it's ease of access here. Or some of the kids will say, well, actually, we thought this pile of writing pens was more important because there's loads of them. Okay, and they're all in a real central location. So the kids came up with lots and lots of categories, all right, for why they think things were best. And actually, in Google's great sort of search of the whole web, although that page ranking thing, which they said is the most important thing out there, Google have to take a lot of those other things into account as well. How new is something? Okay, how relevant is it, or how easy access is it? Okay, is it a website that is easy to get to? Okay, so there are all of these things are factors also in your search. So then what we do, I say, okay, that's great. So we get the children to actually go and we choose some of their categories. All right, so things like, we've already talked about number of, newness, easy access, and we get the children to rank those things 1 to 10. So in place of newness, we might be saying, well, okay, if it's really new, you give it a 10, okay, and if it's really old and rubbish, you give it a 1. So the kids are just ranking that. Okay. If it's easy access, 10 would be, you know, really, really easy to get to, and 1 would be stuck under the cupboard at the front of your classroom. And by the way, when we're doing this, we say to the kids, you're not allowed to move anything. If you find a pencil on the floor, Danny, you have to write pencil on the floor by the bin or whatever, you know, because that's where it is. Okay, it's a search of. Okay. And then all we did is we took that one step further and we just added all those up. I mean, it's really easy to do in a spreadsheet. It's a nice thing to combine a bit of spreadsheet work as well. Okay? Really, really easy to do a simple little formula and just add all those things up. Now, in effect, we've made our own ranking at that point, haven't we? And then if we search that or sort it, which is our next little activity, okay, just sort the whole set of data, largest to smallest, okay, across. And funny enough, it's interesting, you know, we might have thought that was the most favorite, but actually when we've added it all up, the green tray at the front of the class was actually sort of a higher ranking when we gave it all the sort of bits. We got some interesting discussion also with the children about, well, would we weight any of these? Was one thing more important than another? Was it more important, was numbers more important than how new it was? Or the easy access? Well, that's quite easy to do. Yeah, we're thinking of a way we could weight something like this in our sort of our simple little formula. Anybody? No. Okay. Right. Well, all we did is we just counted it twice. Okay, just doubled that value, and so we gave it a little bit more weight in terms of our final sort of score at the end. And actually, the kids really enjoyed the activity, and they got. I think with all of these things, are we explaining the web in its entirety as Les Carr, the computer scientist professor at Southampton University, knows it? No. What we do is giving kids a little way into understanding those set of results when they type in fish on Google, why you get the National Fish Association at the top. There you go. By the way, I made that up, Toby. So, does that make some sense? Yeah? Now, I'll just show you briefly where this planning is. Okay. Oh, there it is. Okay. And by the way, the talks for today are on the web. I'll show you briefly where those are, because it's always nice to be able to take some things away. Okay, so give me a second or two. Let's go into search. Oh, not actually on the internet. Fantastic. Okay. Well, good job we got the slides. No worries. We did set it all up early, didn't we, Les? Anyway, the web link's there, and that web link also goes to a whole load of other activities that go on, and some of those I'll sort of talk you through and take you through now. Okay. Right. Let's go a little step further. Yeah, that would be nice, Les. But, I can always come back to it. Right. Another thing that we do is understanding networks. Okay. And I don't do this as a really long activity, but what I first of all want to do is get the children actually understanding what any network is really. So I use this, and this is on the planning as well. So here's a definition of a network from the Oxford Dictionaries online. Okay, they love stuff online, nice and easy access. And we start off by just saying, well, actually, a network really is just a group of interconnected people. And actually, we can get into where the kids are at as well, can't we? A group of interconnected people. And in fact, the most obvious, easy, internet-connected group of people are your friends and your family. So actually, a really quick sort of little activity with your whiteboards is just to say, okay, we're going to put either friends in the middle or family, and always do both, just in case we've got kids who, haven't got the best family, situations. But they can just write themselves in the middle and just draw some lines and attach, and just, oh look, these are my friends' network, or this is my family network. Okay, and just do that for a second or two. Okay, so really sort of simple sort of way into what a network is. And we'll take it a little bit further from that. Okay. And we've used exactly the same definition, but we've just changed some of the colourings. So it's also a system of interconnected things. And actually, it's worth really not starting with actually networks at this point, or computer networks at all. Well, can we, I tell you what, talk amongst yourselves, can we think of any other networks or systems of interconnected things that we use in us? Anybody?
Us.
Yeah, buses. The bus is a great example there, okay? So there is a network of interconnected bus routes going across Southampton, and of course further afield, there's the big bus, isn't there, or mega bus, goes all around the country, what used to be National Express, I think. Okay. Anything else? Any other networks that we can think of?
Foodweb.
Sorry?
Foodweb.
Foodweb. Foodweb? Yeah. Fantastic. Yeah. Do you mean sort of where our food comes from and where it's sourced from and supermarkets? Oh, well, thank you. Yeah, oh, good to wear off. Yeah. Okay. Yeah, that's another idea of a network. Okay. Did somebody mention train? Did I hear that as well? Yeah. So we've got a train system, a transport system that touches. Come on, there's loads of networks. Sorry?
Sewage.
Sewage, fantastic. The kids love that one. Okay? Yeah, and it's a really good one, isn't it? All of our waste material has to go somewhere. There you go. And there is a whole network okay, of pipes and all the rest of it which go underground, and sewage retreatment plants and all the rest of it, which takes that away and hopefully purifies some of that water and does all sorts of stuff. Anything else? Any other networks? Electrics, thank you, yes. Okay, electric, a really good one. The fact that we've got all these pylons connected all over the place, the kids will probably know of some network substations. Hopefully they won't go and play in them. That's another issue. But, we've got this massive connecting thing that lights out and lights up and runs our computers and all the rest of it. Somebody else mentioned one as well at the same time. It's electric and it's phone, yes. Yeah, a brilliant, another network. Okay, anything else? TV? Yeah, sorry? Roads, yes, yeah. I mean, it's lovely. We've got this overarching transport network, which of course has loads and loads and loads of things in it. But we can break it up into small bits. And we've got roads, we've got trains, we've got bus routes. Obviously, they use the roads, but only certain roads. Okay, so we're just getting the kids into thinking that actually there are a lot of networks that they use all the time. All right? And actually, then we can take it one step further, which is just thinking about a computer network. All right. Now, this is where I think, at this point, I've probably got most of you. But of course, as soon as you get into actually talking about the computer network, all right, I get to be, whoa, step away from the computer network. One of the nice things I do is I do a little role play with the children about how a computer network works. All right, and we're going to have a little mess about and do that in a second. But actually, I don't have to be the most knowledgeable about how all of this works. Because what I also do is I get the kids to write questions down at the end of the session, questions I can't answer. All right, and then actually I use the school technical services. And we send those questions off to them. And we ask them how some of this other stuff works. So, you don't have to be, oh my goodness, I'm not touching networks because I can't answer all the questions. Of course you can't. All right? But you can pass some of those questions on to other people who do. And that's always part of the fun of being a primary school teacher, isn't it? Okay, that you get to do that. On that side, if you haven't got a school network who sort of does those sort of things, okay, I asked a friend of mine, Daniel Fernley used to work for Hampshire County Council, and he runs his own business now. But actually, he's agreed that if you haven't got a sort of a friendly technician in your school or someone you can ask for technical services, you can tweet him, and you can tweet the questions. Okay, and he said he'd do his best to tweet back and give you answers. And he said if you answer himself, we'll go and ask some even more technical people to find out. Which I thought was a lovely thing that Daniel was quite happy to sort of to offer to people. Okay, so please do take him up on that, alright, while you're doing it. So, let's do a bit of role play around this. One of the things, if you go into your school, there will be a cupboard somewhere. And in that cupboard, it will contain all the bits of kit, alright, that frankly, it's that cupboard, you keep the door shut and nobody else goes in. It's all the bits of kit that, let's be honest, you probably think, well, I don't know, I'm not 100% sure what this is, but I better not grab one. Okay? It's sort of, who's got a cupboard like that in your school? Alright. If you have, go and have a look and see if there's anything with these little sort of connecting ports in there, the little sort of holes and stuff. Sometimes you get a really big one. Okay, these are switches. Okay, you don't even need these if you don't. If you can't do this, a box and some string will work just as well. But hey, if you've got the kit in store, why not use it? That's what I work on. All right, these are two I found at my school. All right, and then you'll probably also find some network wires in there as well. Anybody seen some network wires in their school sort of lurking around? Okay, and you could go and buy them if you wanted to. They're only about £1.98 a wire. Okay, and then all I do is we just plug some bits in and we make a little sort of fake network. So we might have over here, do you mind just holding that? Okay, you're the school server. Okay, now the server is just a computer. Alright, but it's a computer that's always on basically, and we do our best not to turn it off because otherwise other people don't get access to the server. Okay? Oh, by the way, because you're the server, you've got a whole load of documents and data and I don't know, school reports and everything else in there, and you're just looking after that for people. And you also have a great big list of all the people who are allowed onto the school network or not, okay? You will check that list when somebody tries to get on the network. You'll just check and have a look at this. You know, let's be honest, in your class, you've probably got a list of the kids in the class, haven't you? So, you know, just something like that. Oh, that's obviously not. Okay. So let's connect this network up a little bit further. Let's go and add a few other bits to it. All right, now of course, depends on how modern your school is. Okay, you might find yourself with an ICT suite. Okay, say you've still got an ICT suite, fantastic. So you're an ICT suite computer, okay, and you're plugged in. And actually, you're plugged into this little box here. Okay, here's a switch, we don't even need to use the names if you don't want to. And that's ultimately plugged into the server over here. Okay? And let's just go and plug in a few other people while we're at it. Okay, most schools have got an office computer, haven't they, somewhere? Okay, I did untangle this earlier, but hey, let's go and see if we can attach someone a little bit further away. Okay, I bet you the switch is going to fall over. Right, health and safety lab, don't watch at the moment, please. Can you just pass that up to somebody there? Fantastic, do you want to hang on to that one? All right, you're the office. That was fun. I hope they got that on video. That'll probably, yeah. So we've got the office computer that's also connected here, and you can see we're just adding some things in. You could, of course, also talk about wireless as well, couldn't you? But at this point, let's not go there. Right. I have had some children who are quite wireless, and we've had some fun bits, and Emma and I were talking about throwing bits of paper to each other to simulate what happens. Let's not go there at the moment. So all we've done is we've connected up bits of the school network. And then all I do is I just go and pretend to log on to some of these computers. So here I am, a year 3 pupil, all right, coming into the ICT suite.
Ow! I guess you're all in now.
I'm sure we've moved that.
Oh, I'm going to spell my name. My name is John, and I think I spell it J-H-N.
Okay, so that little request goes down the wires, goes down through the switch, goes down to the server, and the server checks my spelling of my name to see if I've got it right. Is there anyone called J-H-N?
No.
Oh, server says no. Okay, so it sends a little signal back to me. Oh, I can't get on the network. Mr. Bank! Alright, and then, of course, now John, you've spotted it. With J-O-H. Phonetically spelled, of course. Anyway, type. Oh, got it right this time. Request goes. J-O-H-N? Oh, fantastic. Oh, I'm into the network.
Oh, I was working on a Word document recently, and I would really like to open up my Word document again. Oh, there it is in the list.
Click, click, click. But actually, that Word document is not on this computer. It is actually stored on the server. Server, can we have the Word document? Oh, there goes the Word document. Oh!
Oh, there's my Word document I was working on earlier. Oh, I'm going to do some changes.
Okay, can you see? Very, very simple. I am a very simple teacher at heart. And I do some wonderful backflips. So, you know, very, very simple at this point. Just sort of talking about how the information is stored on one computer and it's just been passed around, okay, and we're accessing. Now, it is more complex than that network. But actually, at Key Stage 2 and Primary, it's really just giving them an understanding of these things, a sort of opening. We can leave that to Key Stage 3 to take on and develop a little bit more. Okay, in reality, all of these computers would have a separate number. Okay, and they would be known to that main server down there by their number, and that would help the communication. There's a little language that goes underneath this. In fact, it's the same language which is mostly used on the internet as well. Okay, it's the same sort of protocol or language that helps them all talk to each other. Right, but actually, if you don't get into that level, it doesn't matter. Because you can tweet some other people and ask them those questions if you get to that point of, oh my goodness, I don't get your dismay. That's fine. That's a really good question. We'll pass that on to a friend of mine, and hopefully they'll have an answer as well. Okay. Does that help a little bit? Okay. And I don't think, honestly, it needs to be too much more complex than that at this sort of starting stage. Okay. Good. Now, and by the way, those activities are on my website as well. Have you managed to? No. I also had some other activities on here, and I was hoping to show you some of those. So have we not got any? Okay, I just have to tell you about them. Sorry about that. Okay, one of the things that we did, and I did this in the last. Who came to the Wessex last year? Okay, so I didn't want to sort of do it again big time. But one of the things we do is a talk about connecting the internet. Okay, how the internet connects. And there is an absolutely fantastic video on there called A Packet's Tale. Right? And A Packet's Tale, it's an American video, but it's how a piece of information goes from England, Oxford in England, all the way to the science website in America, and then the web page comes back. And the kids I've shown it to, there has been a visible wow at the end of it.
We can do it on here.
Oh, brilliant! Yeah, let's do it on there. Actually, I'll get it. So thanks. By the way, it was Les who actually found this for me, so bless you, Les. Okay, let's go find this. Brilliant. Okay. Google. Hey, fantastic. No worries. Right, let me just show you my website as well, and just so you know where the resources are, because I was hoping to do that earlier. Okay, if you go into Google and you type in Junior Computer Science, it's the first link. Okay. Oh, Les, you were saying all nice things about importance and all this bit. Like that. Bless you. And basically, the CS planning stands for Computer Science Planning, and the first one over here, Networks and Internet Planning, is the sort of links to this. Okay, the why there's web searches are like asking your mum where things are. All of that planning is on here as a PDF. So you can print it out. I'm a constant one for tweaking things and improving stuff, and as I do it in another lesson, okay, the kids often change my planning, and most stuff on here has gone through quite a few revisions of what we're doing with it. Okay, and the Packet's Tale video is also on here. It is on YouTube. Who's got YouTube access in their school? Okay, it's getting better, isn't it? More and more schools, but not everybody at the moment. Okay.
Have you ever wondered what happens when someone in England visits the World Science Festival's webpage? First, their computer needs to ask the World Science Festival server for a copy of that webpage. The computer sticks this request into a virtual envelope called a packet, wrapped with specific information about that request, including the World Science Festival's IP address. The computer sends this packet out of the house and below the street via large underground copper wires. It passes through small regional networks before ending up here at Telehouse North in London. Telehouse North is England's main internet hub. The IP address on this packet tells the hub that the World Science Festival server is actually in Los Angeles. So Telehouse North sends the packet out as light across the Atlantic, over fiber optic cables buried deep beneath the ocean. The packet ends up here, 60 Hudson Street, New York City, the largest internet hub on the East Coast. This hub sends the packet through a series of regional networks connecting New York to Los Angeles, where the World Science Festival server resides. The server reads the request and gets ready to send the web page to England. But web pages made up of images and text are too large to send as a single packet of data. So how do we get it back to England? Imagine a group of 5,000 tourists visiting New York City in a single gigantic tour bus. They are way up in Harlem, but they want to visit the Statue of Liberty before it closes. But it's rush hour on a Friday. There's no way that giant bus is going to fit through those crazy congested streets. So they decide to get off the bus and spread out. Some take the subway, some take cabs, a few rent bikes, and some even take kayaks down the Hudson River. How they get there doesn't matter, as long as they get there on time. Likewise, for the internet to work efficiently, this web page is pulverized into thousands of tiny packets of data, each one wrapped with all of the information it needs to rebuild itself in England. The packets are sent to LA's One Wilshire hub, which checks the traffic report before sending them off. Through miles and miles of land they travel, checking in through different hubs. Like our New York City tourists, those packets don't care how they get there, as long as they get there as fast as possible. Most of them will go through 60 Hudson in New York, where they are redirected back to England as light, riding a fiber of glass as thick as a silver dollar. Then back on copper wire through regional British networks until all the packets reach their destination and this epic journey, it all happens in about a second, along with trillions upon trillions of similar journeys that happen each and every day on this remarkable, easy to take for granted network of networks we call the Internet.
So what do you reckon? Good video? Certainly the children that I've shown that to have gone sort of, and actually it is pretty amazing really, when you think about it. Now, I have a little activity that sort of goes with that, which is a honours a Prezi that you can use if you want. Okay, I'll show you that briefly. Okay, who's used Prezi before? Yeah, it's a lovely little communication tool, and it's great because it zooms in and out of bits and pieces, and of course you can access it across the web. Okay, as well. Fantastic. In a few seconds. Brilliant. I tend to combine the video and talking through the Prezi with how things work, and then what we do is we actually, there's a little activity where we use stickers, and the children actually connect up their own network, okay, their own internet, from their house to some web pages. We've got the stickers and A3 sheets that you can use if you want to. So here we go, we're starting straight away in somebody's house. I often talk about the little box that people have got in their houses. Alright, we've got a little box that connects up the internet in your house. And they go, oh yeah. And actually about 8 or 9 kids can normally tell you it's either BT or Virgin Media or Sky, those sort of things. And the kids who don't know, I say, well actually go and have a look, go and ask your mum or your dad, but don't say what is the router, because they won't know what you're talking about. Talk about what's the little box in your house which connects the internet up. Right? And then we take it a little bit further. So what I often do is start off with, well, choose one of these people and forgive the sort of twee characters here. Okay, somebody wants to look up Moshi Monsters on their little device. So they're clicking on that on their iPad, and it sends a single packet of data, just like we saw in the video, and that goes down your phone lines, mostly. Okay, it goes off to your internet service provider, okay, who then goes, oh, well, it's not here, Moshi Monster's not here. It normally goes off to a whole load of other routers that are actually in our country. Okay, and they'll look, they'll say, oh, BBC's here or my school's here, but actually Moshi Monsters isn't, so it passes the information on. And at this point we're starting to go across the Atlantic Ocean in our fibre optic cable. Okay, remember that, what was it, riding the light as a silver dollar of whatever it said in the video, okay? I have to get that one down a little bit, Pat. Well, at this point, I often sort of zoom out and just say, well, actually, if I really drew the internet at this point, I would just cover this place in lights. Okay, and actually, they've been really struggling to map the internet since about 2005, because there's just so many connections, it looks like that string of fairy lights earlier. And here, oh, look, we've got to a router in America at this point, and look, there's Moshi Monsters. Okay, and then we can talk about the web page that needs to go back again. And the nice thing about Prezi, you can just use the back arrows to explain. All right, it's going to break it all up into all these little packets, and off it goes back across the ocean. All right, back through all the local routers in the UK. Okay, back through the phone lines, and back, and suddenly it gets re-put back together again on your web page. Oh, sorry, on your device. Okay, so a little activity there that you can use if that's useful to help the children. I also have a little packet game. Now, kids love sending messages around the class. You know, let's be honest. So we have a little game where we pretend to be some of the packets of data, and we send those around as messages. All right, and all the activity is on there. I did it at the last conference, so I don't want to do it this week, this session. Okay, and finally, there is a really good website, okay, that somebody has made. Oh, right. It is there and it does work. It's obviously blocked it's not blocked in any Hampshire school, so that's cool. And what it does is it maps a single packet of data going across, and it shows you all the little routers that it's gone through, and it also maps it on a Google map as well. And the kids love that because they can see then where things are actually tracing to. All right, and actually I often get kids at the end of that session going away and using the trace route at home, the little version we've got, and coming back and telling me all of their favourite websites and where they are and all the rest of it. Okay, it's not a perfect model because it doesn't actually trace it from exactly where you are. It traces it from a web server in America and a web server in Switzerland. But at least gives the children the idea that the data is bouncing through the routers, and you actually get to see how many routers. You can even, if you're doing it as a class activity, you can say to kids 10 minutes in, right, okay, how many hops did it take you to go to Moshi Monsters? All right, and some kids will say 7, some kids go 9, some kids say 10. You can say why? And do you remember the video? The packets of light go the quickest route. And sometimes that's more hops than others. But actually being able to see that in real time is cool. All right. Sorry, we haven't actually got it on there. But, yeah. Right, can we go back to this one briefly? Fantastic. Oh, it's the last slide. Okay, so basically I hope there's a few activities on there that you can take away and adapt to make them your own. All right, all of the sort of associated planning with those things is there. I know, Sarah, you've got some planning as well, haven't you, on how the internet works as well, on the CAS website? Yeah. Yes. If you haven't joined CAS already, do join CAS. Okay. I mean, there's lots of, and actually you've got some stuff as well, haven't you, Peter? Yeah. And there's, you don't have to just have my idea. There's lots of other people who've got just as good, maybe even better ideas than mine. All right. So please do go on the CAS website, have a look at some of the things that people have put on there, and pick and choose or adapt, or if you come up with a better idea, tell us as well. Always interested in sharing and moving things on. I make it exactly. We on time? Yeah. Fantastic. What's now? Is it coffee and?
Yeah, coffee and cake.
Coffee and cake, and then back in here in half an hour's time. Thank you very much for